Hey everybody, I'm so excited to be presenting on the vocal folds today. I think it's so important for singers and speakers to understand our instrument. You know, if you're a guitar player or a piano player, you want to understand how your instrument works and you can see it and you can understand it really clearly. And sometimes that's more difficult for singers. So hopefully today you'll understand a little bit more about your voice and how it functions. Every musical instrument has three essential components: a power source, a sound source, and a resonator. For a cello, for example, the power source would be the arm, and the sound source would be the strings vibrating, and the resonator would be the body of the cello. For a singer, our power source is our breath, our sound source is the vocal folds, which we're going to talk about today, and the resonator is the vocal tract, everything from your vocal folds all the way up through to your lips or your nose. And I also love talking about the voice as an instrument because it helps us realize that singing is not about talent. We all have a singer's instrument. We all have a voice. We all have the same muscles, bones, and cartilages capable of the same actions. And subtle differences should be celebrated, but everyone should strive for and is capable of proper coordination of your instrument. You didn't cartwheel perfectly the first time you tried, did you? Right? You know, it's all about coordination and it's all about learning. It's not about talent. So we're going to build a little bit of a body map here to understand our voice. And we're going to start by finding our hyoid bone. If you go underneath your chin, sort of reach your fingers back, you'll feel two little notches on either side, two little bumps. It's sometimes hard to find for some people, but you might feel those bumps. That's the hyoid bone. It's one of the only bones in the body that's not connected to another bone. It attaches to the tongue above it, and below it, your larynx is suspended. Your larynx is the thyroid cartilage, which is this cartilage right below the hyoid bone. There's a little divot, then there's the cartilage, and there's another cartilage called the cricoid cartilage right below that. So this is what houses our vocal folds, and our vocal folds are actually very small. In a cis male, they're about the size of a quarter. In a cis female, they're about the size of a dime. A little image here to sort of help you visualize that. And this picture to the right here is an actual picture of human vocal folds. When they're apart, they're abducted. You call it abducted. Abducted vocal folds are apart, and adducted means they come together. And this is the position that they're in whenever we're phonating, meaning speaking or singing. The original purpose of the vocal folds was actually not to sing. It is to protect the lungs from foreign matter. If you've ever had water go down the wrong tube, you've felt your vocal folds protect your lungs. It also helps build subglottal pressure, meaning pressure sort of within the lungs, to help with things like lifting heavy objects, childbirth, and defecation. So if you were to lift an object, you wouldn't breathe out while you do it. You would breathe in, and you would hold that, and even if your mouth is open, your vocal folds will stop the air from leaving your lungs. So that's actually the original biological purpose of the vocal folds. But at some point, humans learned that they can create sound by sending air through adducted vocal folds. And even later, we learned how to make beautiful sounds. And it really is sort of a miracle that we've discovered the secondary purpose of these little folds of tissue. There are a few muscles inside the larynx that cause changes to the shape and positioning of the vocal folds. There are muscles that open and abduct the vocal folds, bringing them away from each other. There are muscles that bring them together. The thyroarytenoid muscle down here, this is actually the muscle mass that is inside your vocal folds. And when it contracts, it thickens and shortens your vocal folds. Then there's the cricothyroid muscle, which thins and stretches your vocal folds. And none of these muscles you can directly control or feel. Whatever you send as a signal from your brain to your voice, your vocal folds, these muscles will put your vocal folds in the right position to make the sound you want. If you say, I want to make a really loud sound, your brain will automatically, contract your thyroarytenoid muscle, your intrarytenoid muscle, and your lateral cricoarytenoid muscle to put your vocal folds in the right position. One way to think about the vocal folds is to talk about onset. How do we start our tone? There are generally considered three types of onsets, though it's really a spectrum, and there's all these different onsets in between these three. On the breathy side is the aspirate onset, when the breath moves first, then the vocal folds come together. In the middle is a balanced onset, when the breath moves and the vocal folds come together simultaneously. Then there's the glottal onset on the other side, where the vocal folds come together, then breath moves to push past them. And they sound sort of like this. A breathy onset would be, ah, ah. You would hear the sort of breath sound in that. And on the opposite side is a glottal onset, where the vocal folds come together, You hear that sort of click or that abrupt start. And balanced onset is right in the middle. Ah, ah. Glottal onsets, if done excessively, can cause vocal damage. And breathy onsets generally are just a less efficient way to use the voice. So we want to strive in our speaking and singing, if you're a singer, to find balanced onsets as the default. Though glottal onsets and breathy onsets do happen all the time in our speech. Anytime you said uh-oh, that requires a glottal onset to make that sort of sound. So experiment with that on your own. And hopefully you've learned a little bit more today about what actually causes the sounds that you make when you speak or when you sing. Thank you so much.